In the previous video, I discussed breaking down data silos and transitioning from data lakes to data warehouses. The next part of your data strategy is learning about your data. Before you start building any ML models, especially models that will drive business decisions, you have to understand your data. Building a dashboard is one of the best ways to understand your data. Dashboards are visualizations of your data that can be seen widely across the company. Use tools such as Data Studio, Looker, Tableau, etc., connected to your data warehouse. Build interactivity into the dashboards and watch what decision makers do with the data and how they interpret it. The general maturity curve is from descriptive analytics to dashboards to machine learning. Use technologies like Vision API, Natural Language API, AutoML Text, and AutoML Vision to enrich your unstructured data. You can pull out features from your unstructured data and add them to your data warehouse. For example, you could run all customer reviews through the Natural Language API and add a customer sentiment column to your data. This will make subsequent ML on this data easier and much more powerful. You can now do ML directly in the data warehouse. You did that when you built a model to predict bike demand in BigQuery. Use this capability to build pilot machine learning models in the data warehouse itself. Your data engineering team can actually do this. The most important advice I have for you is that you should approach these like pilot projects. Don't spend months on a single project. Instead, allocate only a week or so when the data engineering work is complete. Do a lot of projects. In my experience, there are many easy wins possible. So you should focus on quantity at this stage. This also helps your team to develop wide-ranging experience. Integrate the results of the pilot ML models into the tools that decision makers use. For example, if you are building an ML model to estimate bicycle demand, then build it into the navigation app that your product stockers use. In some cases, go to production with the BigQuery ML models that you built as pilots. For promising use cases, build more sophisticated ML models. You might want to hire an ML engineer to help you formulate problems correctly. For extremely promising and valuable use cases, you might want to build custom models using TensorFlow. For this, you will have to hire ML engineers, although some of your data engineers might want to upskill themselves. You might build a team around one experienced ML engineer. Avoid the temptation to go deep too fast. Do many pilot projects and be selective about which projects might be helped by additional accuracy. In many cases, a suitable model provides 90% of the business value, and the remaining 10% will involve a significant amount of work. Pilot models might be fine in batch mode, so you can run them on last week's data, for example. But ML models gain value when they are real-time and are run on fresh data. Now you'll need to build the IT infrastructure to get data in real time. Of course, the ML models were trained on data across your organization. So this means that you need to get such data across your organization in real time as well. All the silos you broke down for historical data, You need to break them down again for real-time data. Just as a global serverless warehouse such as BigQuery was useful for collecting historical data, a global serverless messaging system such as Cloud PubSub is also necessary for collecting real-time data. As with BigQuery, the department who owns the data in PubSub can provide access to others without assuming the cost of their compute. Next, collect more data. Think carefully how you can add more data to improve those models. Think about the data you have and also the data you can collect. Sensors are cheap, so develop an IoT strategy. Build partnerships around data. Make sure to add metadata to all of your data sets.